Okay, in this problem it says a swing ride at a carnival consists of chairs that are swung in a circle by 15.0 meter cables attached to a vertical rotating pole, as the drawing shows. So the cable itself is 15.0 meters. It's not the radius. This radius here of the circle, that's obviously less than 15.0 meters, but as you can see, it should be easy to calculate that. Suppose the total mass of a chair and its occupant is 179 kilograms. Determine the tension in the cable attached to the chair, and then find the speed of the chair. Okay, of course this takes on centripetal force, so I'm going to write down sum of the forces equals mass times velocity squared over r. Notice that v squared over r, the centripetal acceleration, always goes on the right hand side. Well, on the left hand side I need to supply forces that are at hand here. I'll talk about them in just a moment. So the centripetal force itself, this part over here, or centripetal acceleration, goes to the right hand side. On the left hand side I have forces like weight, tension, normal force, things like that. Okay, let's see what we got here. They're going to ask for the tension. So tension is in the cable here, T, and we don't know what that tension is, so I'm going to make a question mark there. What else we have given is that the mass is 179 kilograms, which means we also know that the weight equals 1,750 newtons. It takes a moment to calculate. So the weight here, so that one is given. The mass is given. And here on velocity squared over r, well, we don't know what that is. We do know what the radius is. That's easy to calculate. In fact, let's do that right now. So r equals 15.0 times something, cosine or sine of 60 degrees. Well, I don't like angles being measured from the vertical, so I'll be measuring the angle here from the positive x-axis. So I'm going to have, let's see, that one is 150 degrees. And then I'm going to take 15.0 times the cosine of 150 degrees. Comes out to negative 13.0 meters. And that negative is important too, because at this point here, the chair, as it's going around this way, will be moving towards the left, will be attracted due to the tension to the middle of the circle here, and the radius is being measured to the left, so it's a negative 13, so that's important. So that whole thing here, the acceleration at this point is negative, which makes sense because the chair is being accelerated to the left. Also notice that the horizontal component of the tension is also negative, so we'll have a negative over here and we have a positive over there. In any case, let's see what kind of forces we actually have. We have tension, and we have weight. And the weight is not just going to vanish here. The weight, actually, part of the tension, the y component here, needs to hold up the weight, while the other part of the tension, the horizontal component, actually gives it its swing around in this horizontal circle. Equals mass times velocity squared over r. Okay, now the tension is to the upper left, the weight is down, so we do need to split it up into x direction and y direction. In the x direction, we have tension times cosine of 150 degrees. This one overall here is negative, and that makes sense because the tension is pointing to the left, plus the weight in the horizontal, that's of course 0, equals mass times velocity squared divided by the radius, which by now we have calculated as negative 13. Again, this one is negative and this one is negative, so that makes sense. In the y direction, we have tension times the sine of 150 degrees plus the weight. Now, what does that equal? Well, it says consists of chairs that are swung in a circle, attached to a vertical rotating pole. In any case, what they're saying here is that the motion is in the horizontal plane, and nothing happens in the vertical. So nothing changes in the vertical. That means that the two forces over here in the vertical need to equal 0. Because if they weren't, then the lift would the chair would either lift or it would drop, and they don't say that in the problem. It's supposed to stay in the horizontal plane. So that equals 0. Well, this readily tells us what the tension is. So tension equals weight divided by sine of 150 degrees. Oh, whoops, because I got the weight to the other side, that's actually a negative being introduced here. And the weight itself is negative, so minus minus is going to give us a plus, with the sine 150 degrees being positive. And so we're going to get a positive tension here. Notice that later on, this part here will be the negative part for the tension, pointing to the left. Now over here, I'm supposed to solve for velocity. So velocity is going to be the tension that I just calculated times cosine 150 degrees times r divided by the mass and take the square root. So here the tension was calculated as a positive number. The cosine 150 is a negative, and that gives the horizontal tension the negative. So that's a negative. This one is a negative, which is good because those two negatives cancel each other out under the square root. So we can actually take the square root of that positive number, come up with a velocity. And now you could argue, well, maybe if I chose the positive part of the velocity, it goes into the page here, and if I choose the negative, it comes out of, that's actually kind of a third dimension. So let's just use the positive part of that when we take the square root.